All right, so example 3 now, and we start to push up against my limits as an artist, but roughly this is what the diagram looks like. So I've got 3 tennis balls, each of diameter 6 centimeters, just fitting into a cylindrical can. I'm asked for the volume of 1 tennis ball of the cylindrical can, and then the the volume of the can not occupied by the tennis balls. So part 1, the volume of a tennis ball. So tennis ball is a sphere. So volume of a sphere formula is 4 over 3 pi or cubed. All right. So just be careful. It's the radius that goes into this formula, and it is the diameter of the tennis ball, which I'm given 6. Okay. If the diameter is 6, radius is just 3. All right. So the volume is 4 over 3 multiplied by, I'm told to give my answer in terms of pi. So I'm not going to sub anything in for pi. I want something pi as my answer. So 4 over 3 multiplied by pi multiplied by the radius cubed is 3 cubed. So on the calculator, 4 over 3 multiplied by pi multiplied by 3 cubed is 36 pi. And in terms of pi, that's the answer I want. So 36 pi. It is still centimeters cubed, so do still put your units in centimeters cubed. And that's answer 1. 2 then is the volume of the cylindrical can. So the volume of a cylinder is pi r squared h. So I have the radius of this cylinder already. I'm told that these spheres just fit into the cylinder, okay? So the radius of the cylinder must be 3. I need the height of the cylinder as well, okay? Well, the diameter of each of these tennis balls is 6 centimeters, okay? So that means basically each one is 6 centimeters tall, almost. So that's 6, and that's 6. So overall, the height of that must be 18 centimeters, okay? So I have my radius and I have my height of the cylinder now. So it's again in terms of pi, so I'm not going to sub anything in for pi, multiplied by 3 squared multiplied by the height is 18. So pi multiplied by 3 squared multiplied by 18 is 162 pi. Again, that is in centimeters cubed, and that's answer 2. All right. Answer 3 then is the volume of the can not occupied by the tennis balls, so the bit of kind of space around them. Bits down here, bits down here, bits up here, bits up here. You might also call that the volume of air that's in the cylinder. So we don't have a direct way of getting that. What do we know? We know the volume of the overall cylinder. I know the volume of a tennis ball. So if I do the volume of the overall cylinder, take away the volume of the 3 tennis balls, I'll be left with just the volume kind of around the spheres inside the cylinder. Okay. So for part 3, I'm going to do area of the cylinder, volume of the cylinder, take away volume of the 3 tennis balls. Okay, so just be careful here. In part 1, you just got the volume of 1 tennis ball. So in part 3, the first thing you're going to do is get the volume of 3 tennis balls, which is the 36 pi multiplied by 3. Plug that into the calculator and you'll get 108 pi. All right. So the volume of the, as I say, the fresh air, or the volume of the can not occupied by the tennis balls, is just going to be 162 pi take away 108 pi. So 162 pi take away 108 pi is equal to 54 pi. It's still volume, so it's centimeters cubed. All right, and there's your answer for part 3. It is still 54 pi, okay? So something pi, take away something pi, you will have pi in your answer. Just like in algebra, if I did 5x, take away 2x, my answer will be 3x, okay? The kind of pi here operates like a variable would in algebra. So you don't go pi, take away pi, it's gone. You will have pi in your answer. If that's going to trip you up, do it on the calculator like I did. But 54 pi centimeters cubed is my answer in terms of pi. That's what I'm asked to do.